Lesson 6, Database Settings. Autodesk Fabrication CAMduct relies upon settings within the database to create and edit sheet metal parts and items. Autodesk Fabrication CAD MEP and Fabrication STMEP use the same database. There are settings which apply to all of the products and some that are only applicable within Fabrication CAMduct. For this lesson, you'll do the following. Learn to back up and clone the database. Understand the fittings, settings, and options. The exercises in this lesson make changes to the Fabrication Imperial Content database. It's a recommended best practice to back up the database on a regular basis and especially before making significant changes. The database is not a single file but a folder structure with many files. The procedure for creating a database backup uses Microsoft Windows Explorer to make a copy. Open Windows Explorer and browse to the database location. The default location of the database on your computer is C, Users, Public, Public Documents, Autodesk, Fabrication 2015, Imperial Content. If you have a shared database on a network server, you can learn the location of the database by starting Fabrication CAMduct and looking at the path under the configuration name. Right-click on the database folder named version 3.01 and choose Send To on the shortcut menu. Select Compressed or Zipped folder. The folder and all subfolders and files are copied into a compressed folder. It is recommended that you create backups of the database after installing the software and before any changes are made. Shared databases should also be automatically backed up at regular intervals. It is often desirable to clone an existing content configuration for a specific project. Fabrication CAMduct provides a utility to clone an existing configuration. Click the Windows Start button and select All Programs, Autodesk, Fabrication CAMduct 2015, Autodesk Fabrication Migration Tool. The map to ADSK Migration Tool appears. Select Import Fabrication Configuration. This choice copies an existing configuration and adds it to the list of available configurations in the Fabrication CAMduct Start screen. The Browse for Folder window appears. Browse to the default location of the Imperial Content configuration. This is located in C, Users, Public, Public Documents, Autodesk, Fabrication 2015, Imperial Content. Highlight the version 3.01 folder and choose Select. The CAMduct dialog appears asking for a name for this cloned configuration. The default name, Copy of version 3.01, is acceptable for this exercise. Click OK to accept the name. The utility copies the configuration to the default configuration folder. A confirmation dialog appears when the cloning process is complete. Click OK to dismiss this dialog. Close the map to ADSK Migration Tool by clicking the red X at the top right of the window. The settings for fittings include material specifications, connectors, and options which affect flat patterns. Start Fabrication CAMduct and select the Copy of version 3.01 content configuration. Select Create Blank Job. Select the Database button on the utility bar. The database window appears. Select Fittings and highlight Materials in the left menu list. The right pane toggles between Main and Insulation materials. Verify that the Main button is selected. Main materials are the primary materials used to manufacture items. These include galvanized sheet metal, aluminum, stainless, and more. Insulation is typically applied to the parts made of the main materials. Select the drop-down menu for Material and expand the Ductwork material group. Because the database is shared by the other fabrication products and accommodates plumbing and piping items, the choices also include other materials for those items. Choose Galvanized in the list. The list pane below displays settings for galvanized sheet metal. Resize the database window to see all of the columns listed for galvanized metal. The galvanized material is listed by wire gauge, which is its thickness. There are specifications for each gauge. Sort the list view by wire gauge. Click on the wire gauge column header. The list is sorted in descending order with the heaviest gauges at the top of the list. Smaller gauge numbers have thicker material thickness. 16 gauge is about 0.06 inches thick, which is about 1/16 of an inch. 22 gauge is about 1/32 of an inch thick. Highlight the listing for 24 gauge and review each of the columns. Machine specifies which machine or machines can receive cutting instructions for this material. Some machines, such as water jet tables, are intended to cut insulation, whereas most plasma tables can cut galvanized sheet metal. Thickness is the actual thickness of the material in inches. Wire gauge is the standard classification for sheet metal material thickness. Cost is the price of this material per pound. Default size is the standard sheet size for this material. Sheet sizes are matched to the size of the plasma table. Most tables accept sheets that are 60 inches by 120 inches, or 5 feet in width by 10 feet in length. Some tables can accept larger sheet sizes. Weight is listed in pounds per square foot. The last column indicates whether items fabricated of this material can be sent to a decoiler unit. Another method to review all material settings is to select the Print Materials button just below the main button. Select this button. You're asked if you wish to print all materials. Selecting Yes will print preview all materials in the database. Selecting No print previews only the material selected in this window. Cancel will cancel the print command. Select No to preview only galvanized sheet metal specifications. A print preview window appears showing specifications for this material. Click the red X to close this preview window. Double-click the 24 gauge listing in the material list pane. The Edit Gauge 24 window appears. The same settings are listed, but these can be changed by selecting the value. At the bottom is a tabbed interface for sheet sizes for each machine type. The flatbed tab is selected. Additional sheet sizes can be entered here to accommodate different machine capabilities or needs. Only one sheet size can be set as default. The green check mark indicates the default sheet size for this gauge of this material. The red X deletes a sheet size, whereas the green Add New button enables creation of additional sheets. Click Close to exit this window. Below the Print Preview button is the New Gauge button. Select this button and the Edit Gauge window appears. Enter the following settings for this new gauge. Thickness is 0.1046. Wire gauge is 12. Cost is 0.53. Weight is 4.267. Click in the Flatbed tab area and select New Sheet. Enter 120 for the length and 60 for the width. Click Close to save these settings and exit the window. The new 12 gauge sheet specification appears at the bottom of the list pane. Resort the list view by clicking the wire gauge header twice. The new gauge appears at the top of the list. Highlight the 12 gauge you just created. Right-click and a shortcut menu appears. Edit is the same as double-clicking on the gauge in the list view. It opens the Edit Gauge window. Copy enables copying this gauge to this or another material specification. For example, you could copy the 12 gauge specification to the mild steel material. Duplicate copies this gauge within this material. It opens the Edit Gauge window with duplicate settings. Delete erases the gauge. Select Delete and a confirmation dialog appears. Choose No and the Delete command is cancelled. To the right of the Material drop-down menu are buttons to edit, create, and delete materials. Select the Add New Material to Database Now button. You're asked if you want the gauges and default sizes copied from the current material. Copying sizes and gauges from a similar material can save time when creating a new material. For this exercise, choose Yes. Another confirmation dialog appears asking if you want the current material specification copied to the new material. For this exercise, choose Yes. The Materials Properties dialog appears. Name this new material Platinum. Create a new materials group named Wealthy. Enter PLAT for the abbreviation. Click OK to save these settings and close the window. The new platinum material is shown in the list view pane below. The next group of settings is for seams. In the left menu, select Seams. Make sure the Manufacturing button just above the list view pane is selected. The many types of seams available within the software are shown in the list view pane below. The settings for each seam type are displayed in the list view pane. Double-click the large Pittsburgh seam type. It is labeled PITTS-L. A window appears in which you may change the settings for this seam. These settings control various aspects of the large Pittsburgh seam. Close this window without making any changes. Above this list view pane is a pull-down menu for seam types. It is currently set for seams. Select this drop-down menu and choose Oversize Seams. Only a few types of oversized seams are available. The settings for each of these can be edited using the same process as for regular seams. Change the type back to seams. The next group of settings is for connectors. In the left menu, select Connectors. The list pane on the right shows connector groups. Make sure the Manufacturing button just above the list view pane is selected. Expand the group named Duct Flanged Connectors in the list view below. Three types of flanged ductwork connectors are shown: DuctMake 35, PC, and TDC. Double-click the TDC connector listing. A window appears with detailed information about this connector. The turnover and straight settings control how much of the sheet metal is bent to form the specified connector. The type of notches to be cut is specified here as well. Select Close to close the window. Expand the connector menu item and select the notches. The details for creating various notches are shown in the right pane. Using the Notch drop-down menu at the top of the pane, choose the TDC notch. Notches for connectors may occur at seams. The Use Seams setting and the drop-down menu for Display Seam illustrate how the notch is configured for each seam condition. The seam does not have a direct effect on the notch, but is useful for visualizing the notch. The list of seams is taken from the seam database. Notice how the TDC notch appears with the large Pittsburgh seam selected. In the Display Seam drop-down menu, choose Small Pittsburgh. The notch display changes. Below the Display Seam setting are the male and female angle settings. Change the male angle to 45. The male notch shape changes to an angled cut. Change the female angle to 45 and observe the change. Change the female angle to 0. An error condition occurs. The female angle setting turns red and both notch display windows illustrate bad notch designs. Change both notch angles back to 90 degrees. The error condition is corrected. The tables at the bottom of the pane are for defining the notch dimensions. Click the Print button at the top left of the pane. A dialog asks if you want to print all notches in the database. Click No to print only this TDC connector notch at a small Pittsburgh seam. The Print Preview window appears with details about this particular notch. Click the red X to close the Print Preview window. Ducts can become wider than their sheet material can support. Rather than increase the thickness of the material, supports can be installed to strengthen the duct. These supports are called stiffeners. They can be applied externally or internally. External stiffeners are usually small angles that are fixed horizontally to the outside of the duct and act as small beams across the width of the duct. They can be fixed with welds, screws, or bolts. Internal stiffeners are usually pieces of metal electrical conduit placed vertically inside the duct. They act as columns to support the top and bottom of the duct. They are fixed through holes in the duct with conduit nuts. In the left menu, select Stiffeners. The list pane on the right shows stiffener groups. Make sure the manufacturing button just above the list view pane is selected. The list view displays information about each type of stiffener. The list of stiffeners is lengthy. You can filter this list to find a specific stiffener. Right-click on the header and choose Filters from the shortcut menu. The Column Filters window appears. Enter TR as the name value and click OK. Only stiffeners with names starting with TR are displayed. Highlight the TR plus 6WG3 item in the list. The names of these stiffeners include codes that explain the specifications. TR is an abbreviation for tie rod. Plus 6WG indicates that this tie rod stiffener specification is designed to work with the plus 6WG ductwork specification. The 3 number in parentheses means that this stiffener specification is intended for ducts up to 3 feet long. Additional stiffener specifications accommodate ducts that are wider. Double-click this item and the editing window appears. The name of this stiffener specification can be changed in this window. Central type refers to how this stiffener is applied to ducts. Some wide ducts require stiffeners installed at intervals along the length of the duct so that the center won't collapse. This can be set to none, internal, external, or both. Internal stiffeners are tie rods, whereas external stiffeners are angles. This value is set to none, so no stiffeners will be installed along the length of the duct. End type specifies what type of stiffener is applied to the ends of the duct. This value is set to internal, so tie rods are used at both ends of the duct. Select the Breakpoints button at the lower left corner of the window. The breakpoints for this stiffener specification appear. Breakpoints determine how many stiffeners are installed in a duct. The first column is labeled less than or equal to length, but in this view pane, this applies to the width of the duct. The first column determines the width of the duct. In this case, there are 3 width categories. Stiffeners for ducts with widths less than 48 inches are controlled by the first line. It indicates that no stiffeners are installed along the center of the duct, and none are installed at the ends. Thus, ducts narrower than 48 inches have no stiffeners. Stiffeners for ducts 48 inches wide and less than 999 inches wide are controlled by the second line. It specifies no center stiffeners and installs 1 stiffener at the ends. The stiffener would be installed at the midpoint of the duct width at both ends. Ducts that are 999 inches wide or wider receive 1 stiffener at the end and 1 in the lengthwise center. Additional specifications can be added using the green Add buttons. Specifications can be removed using the X button. This window displays width-based specifications. Along the top of the window are buttons which display length-based or span specifications and external specifications. Select Cancel to close this window. Close the Stiffener Specification Edit window. Select the Specifications menu item. Change the specification drop-down to plus 6 WG galvanized if it isn't already selected. Click the 3.0 tab. This is a breakpoint table that applies to ducts that are up to 3 feet wide. The duct widths are each row in the breakpoint table. Expand the width of this table or scroll to the right to see the stiffener column. The TR plus 6 WG3 stiffener specification is applied to certain duct widths within the 3.0 length category. Return to the Stiffeners menu item. Right-click on any stiffener item and a shortcut menu appears. Edit is the same as double-clicking on the item. Breakpoints directly opens the breakpoint tables for the item. Change Group enables you to organize stiffener specifications into groups. Print opens a print preview window with the selected stiffener specifications. Select all of the TR plus 2 WG stiffener specifications. Right-click and choose Print from the shortcut menu. A print preview window opens showing the settings for these stiffener specifications. You can page through this multi-page report by clicking the right and left arrow buttons. Click the red X to close this window. Expand the stiffeners listing in the left menu to display the components which make up the stiffeners. Select the Ancillary Materials menu item. Various types of ancillary items are listed in the right pane, but they are grayed out. This indicates that some or all of the properties for these items are locked and may not be changed. Autodesk and other content providers sometimes lock items' properties to prevent changes. Select the Tie Rods menu item. Only one item is listed in the list pane. It is a 1/2 inch diameter EMT, which is metallic electrical conduit. Splitters are used in wide elbows and bends to maintain smooth airflow. These are partitions within the duct that subdivide it into smaller air passageways. Unlike air turning vanes, splitters extend through the length of the fitting. In the left menu, select Splitters. The list pane on the right shows splitters. Make sure the manufacturing button just above the list view pane is selected. Double-click the standard splitter listing. The splitter edit window appears. As with previous specifications, the values for this splitter specification can be changed. Notice that the minimum angle is set to 45 degrees. Splitters will not be added to wide ducts with a direction change of 45 degrees or less. These specifications control where the holes will be cut for fixings. Click the Breakpoints button. The splitter standard breakpoints window appears. As with other breakpoints tables, the first column establishes size categories. Fittings that are less than 24 inches wide receive no splitters. Fittings that are at least 24 inches wide but less than 36 inches wide receive one splitter. The columns listed as number 1, number 2, and number 3 are for the splitter spacing. The values shown space the splitter equidistant from each other to divide the air passage equally. The setting at the top of the window sets these values as percentages of the fitting throat width. Where there is only one splitter, it is located at half the width of the fitting. 2 splitters are positioned at the 1/3 points. 3 splitters are spaced out at 1/4 points. Click Cancel to exit this window. Close the Edit window. Expand the splitters listed in the left menu to display the fixings. Select the Fixings menu item. Various types of fixings are listed in the right pane, but they are grayed out. Air turns are also known as turning vanes. Like splitters, air turns help guide the air around a turn in an elbow or bend. Unlike splitters, air turns are short-angled or curved guides. In the left menu, select Air Turns. The list pane on the right shows air turns. Make sure the manufacturing button just above the list view pane is selected. Double-click the small DBL vane air turn listing. The splitter edit window appears. These settings control vane spacing, track width, and more. As with previous specification, the values can be changed. Notice that the minimum angle is set to 45 degrees. Splitters will not be added to wide ducts with a direction change of 45 degrees or less. Close this window. Expand the air turns listing in the left menu to display the components that make up these air turns. Select the Air Turn Vanes menu item. The 2 types of vanes are listed in the right pane, but they are grayed out. Select the Air Turn Tracks menu item and view the tracks listed in the right pane. These tracks are paired with vanes for a complete assembly. Select the Fixings menu and notice the fixings listed in the right pane. Select Effective Diameters in the left menu. This table specifies actual dimensions when material thickness is taken into account for various connections. The 3 diameter types of a circular duct or fittings are nominal, inside, and outside. The terms generally apply to the position that the diameter is measured from. When working with round fittings and ducts, it's important to establish which diameter type is being used for the flat pattern development. The software can produce flat pattern developments using one of these types. For example, consider 2 round ducts that are exactly 12 inches in diameter. If one duct is supposed to slide into the end of the other, it cannot because the 2 ducts are exactly the same size. This table makes small adjustments to the flat pattern so that the ducts can fit together. Select the Pattern Switches menu item. Choose the Take-Off tab if it is not already selected. Enabling the Display Locked Dim setting causes all locked item dimensions to be visible in the Take-Off window. This is useful to confirm that the item sizes are correct, even if you cannot modify the dimensions. The Show Hidden Option setting and the Display Locked Option setting are similar in that they cause hidden and locked item options to be visible in the Take-Off window. The Help setting enables the Pattern Help tab in the Take-Off window. The Enter Imperial Dimensions in feet toggles the entry from inches to decimal feet. For example, you would enter 0.5 feet rather than 6 inches. The Allow Double Wall Entry setting enables the double wall setting on the Item tab in the Take-Off window. This then enables an item to be made with double wall skins and insulation. Select the Developments tab. The Effective Diameter setting enables use of the effective diameter table when calculating the finished sizes of round ductwork. Parts labels on inside cause the flat patterns to be created and sent to the machine with the inside surface facing up. This is so that part labels can be easily applied to the inside surface of the parts. Insulation labels on inside is the same setting, but for insulation cutting. The Cut Insulation option enables creation of flat patterns for insulation for fittings. This setting is quite useful for nesting insulation separately from fittings. Scroll to the bottom of the Development Settings list. The Cut Collars options enable creation of collar flat patterns for round, oval, and/or rectangular connectors. Select the Views tab. The settings within the Take-Off Display on Views group control the visibility of annotation within the viewports of the Take-Off window. The settings in the Printing Display on Views group control the visibility of annotations for graphical print objects on worksheets, labels, and reports. Select the Pattern Options menu item. Click the General tab if it is not already selected. The Machine Cut Straights setting controls whether straights are controlled by the fittings specification or the straight specification. Close the database window.